Okay, well, hi everyone. Thanks for tuning into today's webinar on managing the charge from your multi-head weigher to your VFFS machine. My name is Emily Brogan. I'm the marketing manager for ROVEMA North America. And before I get started, I do want to go ahead and get a couple of housekeeping notes over with while folks are still joining us. We are recording this webinar and we will send you the access link in a follow-up email on Monday. Please, if you want to submit a question, use the Q&A function at that bottom bar of your screen to submit any questions you may have. We'll get through as many as we can. If we don't address your question in person, we will get you the answer in an email early next week. So I have several panelists to introduce to you all that will be helping us as we unpack our topic today. First, I want to welcome Don Lawrence. He is the Technical Parts and Warranty Specialist with ROVEMA North America. Don, thanks again for pitching in on a second webinar with me now. Don, how long have you been with ROVEMA?
I have been with ROVEMA since 1989. And the first 28 years that I was with ROVEMA, I was in the service department, traveling and installing and troubleshooting machines. And now I am in the office and technical parts and warranty specialist.
Thanks, Don. Second, I'd like to introduce Carlos Rochetta. He is the area manager with ROVEMA Latin America. Carlos, could you share a little bit of your background with ROVEMA as well?
Hi, Emily. Thank you for the invitation to the webinar. I've been working for ROVEMA since 2013. I started as a service technician. I traveled around Latin America for 2 years. And then I jumped to the sales team, and I am in charge of the southern region of Latin America. So Peru, Chile, Argentina, and other countries nearby. So that's it.
Awesome. Thanks, Carlos. So last but not least, we have Kyle Lasecki on our call today, who joins us from MULTIPOND America. Kyle, could you give us some of your background with MULTIPOND?
Yeah, thanks, Emily, for having me here. I'm excited to talk about the various scale experiences with everyone today. I've been with MULTIPOND for just over 10 years. We're in Wisconsin. It's naturally cold up here, so I hope everyone is safe from the storms we've been having this past week. Like Don and Carlos, I also started in service for about 2 or 3 years, and I moved into applications for 5 to 6 years. Worked on various projects, R&D, even I helped customers on site with issues and installs as well. And for the last 2 years, I've been sales manager.
Awesome. So it's obvious we have a lot of technical expertise on our call today. Before we really dive into some case studies and some best practices, let's travel the journey of your products, and we're going to walk through the anatomy of these components. So just from a very top level, you're going to see the in-feed conveyor coming from the processing equipment. So then that is going to drop the product into a vibratory crosshead feeder, which is going to keep that steady flow product coming into the top of the multi-head weigher, which is feeding into the vertical bagger. So today we're obviously just going to be focusing on the bottom two components. So let's take a deeper dive into the anatomy of these two specifically, just so that we're on the same page as we're diving into specific issues. So Kyle, since you're our scale expert today, why don't you go ahead and walk us through the anatomy of this multi-head weigher?
Sure, thanks, Emily. First of all, please note that this webinar is not a sales pitch or a fix-all to your particular issue. MULTIPOND and ROVEMA together, we're just here to freely express our first-hand experiences to some specific challenges and what it took to fix them. All right. It may cover some broad related topics as well as details between the transition from the scale to bagger. So small disclaimer, please take these instances with a grain of salt and correlate as much as you can with what we have to your specific solution. So for an overall view of the scale, what you see here is a 14 head, 1 liter scale. MULTIPOND makes them from 10 heads all the way up to 36 heads. The size of the scale is kind of dependent on many project aspects, the speed, accuracy, product characteristics, mixing if we need to, headspace, bulk density of the product, a whole slew of different characteristics. On the very top is the distribution cone. This is the number one spot, first spot of the contact to the scale. Its main purpose is to evenly distribute products from the cone to the feed trays. In my personal experience, this is one of the main focuses for all products, for all customers to look at. Just like they say with you eating food, easy, what you put in your body is what you get out. It's the same thing for the scale too. Focus on top of the scale and the rest of the scale should follow. We make two styles for the cones, rotary, vibratory, and there's an integrated pre-weigher underneath the cone that controls the amount of product coming to the scale. From there, the cone vibrates to the feed trays, and their simple job is to vibrate the product to the hoppers. It's all integrated with the scale and the settings inside the monitor. From the feed trays, it drops into hoppers. Multipond calls them pre-feed and weigh hoppers. Some people are more familiar with calling them pool hoppers. The first hopper on the top is a pre-feed that essentially just stages the product. It just holds it and waits it for the weigh to do its work. The weigh hopper, the second one, is essentially the money maker of the scale. It what weighs the product, it what makes the combinations. After that, after the combinations are found and dropped, it goes through the chutes and funnel. And primarily, this is our main focus today, to talk about that transition point. How do we help that, what to look for? How do we make different solutions for that? What else pictured is a cabinet. All our controls are housed in here, electronics, power, communication boards. The scale is IP69, so it has sloped roof, sloped angles and seals. And then on the very bottom is the timing hopper, which holds the collected weight. We'll talk about that more in more detail in the slides to come.
Awesome. Thanks, Kyle.
Mhm.
So Don, do you mind doing the same for this stripped down diagram of a bagger?
Not at all. Thank you, Emily. What you're seeing here is we have the transition funnel at the top of the forming set. This is what is catching the product that has been released from the scale. And from that point on, it slides down the forming tube or the filling tube. Now you will at some point, some people have a inner filling tube, which is where the product will actually slide down its own tube, allowing air to escape as the product is being pushed through the forming set. At just below the forming or the transition funnel, you have the forming collar, which takes the film from a flat roll stock through a series of rollers to create a little bit of tension on the film so that it will track properly on the forming collar, giving you a good controllable vertical seal. And we form this into a round tube, and the vertical seal bar that you see there is sealing the round tube after we formed it, sealing it together so that we now have a round tube. And then below that is the jaws, which you have one set of jaws. They have two purposes. They seal the top of the jaws, seal the bottom seal of the bag. The bottom of the jaws seal the top seal of the previous bag. Once the jaws have touched, as soon as the jaws touch, that's when we want impact of the product that is coming through the forming or the transition funnel. And once the product impacts with the jaws, as soon as the jaws close, that gives us a maximum amount of settle time for the product to completely settle on top of the jaws before the jaws open up and release all of the weight of the product onto the hot seal so that we don't separate the seal. The jaws are supporting the weight of the product. We also, at the lower end of this, we begin to open up the jaws very slowly to have a controlled release of the weight on the hot seal. And at the same time, we're forcing air, cold air in there to cool and cure that hot seal back to a solid state. At the same time, the knife has cut and separated the two bags so that the previous bag will now drop onto an exit conveyor, and then the next bag will be transported down between the jaws, and we repeat this cycle over again. Is that pretty
Awesome.
much what you want?
Yep. Thanks, Don.
You're welcome.
Yeah, so just to give everyone some context, for folks that aren't hands-on with this equipment, it's often assumed that the biggest driver of production speed is how fast a VFFS machine's seal jaws can cycle sealing each package, like you just described on. But I know for a fact that 75% of the people that are listening on this call today are shaking their head because sure, overall production speed, it does top out for each machine when you're running like the dream product, but this is reality. And your products, your customers, they want the fluffiest popcorn, they want the stickiest sugar-coated candies, they want every bean they want every bean of their coffee to be perfectly whole when they open up that package. So when we talk about high speed, those less than ideal products, they have tendencies, and those tendencies often become speed bumps. So today, our experts are going to dive into some of the most common tendencies, and then we're going to pair them with best practices, and we're going to then open it up. We're going to open up the Q&A feature so that we can help more of you out with additional issues. So first of all, Carlos, when we were discussing the topic that you brought up a recent story about the issue of running different package sizes and weights. And let me just go ahead and get this slide up. You know, flexibility in packaging machinery, it's imperative. So walk us through that story that you told us, and then let's unpack some solutions around setting yourself up for success in this category.
That's right, Emily. As you already mentioned, a lot of requirements the customers have for the product that they are purchasing, but we also have to think about what are the requirements of the factory in terms of flexibility. Flexibility, as you mentioned, is very important, and we want to take advantage of the equipment we purchase to make it operative for all the range of products that we want to sell. And it happens a couple of years ago, a customer bought a multi-head weigher and a vertical form fill seal machine from us, and they wanted to pack marshmallows at a very fluffy, lightweight product, and with very different weight range, so 30 grams and 200 grams with the same machine, same weigher. And you have to be very careful in these occasions because if you talk to the two vendors, to the multi-head weigher vendor and the vertical form fill seal vendor, they will see their own perspective of the product, but you have to make them work together. For example, if you have 30 grams of marshmallows, there are only 6 pieces, 5 to 6 pieces of marshmallow. And if you buy a multi-head weigher that needs to allow you to pack 30 grams and also 200 grams, the requirements are very different. And if you want to pack 200 grams, you end up with a huge weigher with a huge tiny hopper that's probably 200 millimeters wide. And this 5 or 6 pieces of marshmallows, when you're packaging 30 grams, they spread out in this 200 millimeters of tiny hopper. And then you have to direct all that product in a 70 millimeters forming tube. And that is very difficult to do. The products, as soon as you release the charge, the products start jumping in the sides of the timing hopper, and that is that it takes forever till you get the product in the bottom of the bag, and you have the danger, you have the risk to end up with a perfect vertical form seal machine that can run 120 bags per minute, a perfect multi-head wear that can also run 120 bags per minute, but altogether you won't even reach 60. So the way this transition is planned between the multi-head wear and the vertical form fill and seal machine is very important. And you have to be completely transparent with both vendors of what you intend to do and how you intend to do to find the best solution.
So I know when we were talking about this in preparation for this call, you did pose, you know, it's tough, but if folks want to run a variety of package weights, there are some capabilities that give you that flexibility, right? And that might be a question, some for Kyle as well. What are some solutions?
From a Multipond perspective, we always try to get as much information as much as possible. No detail should be left behind, but even knowing the forming tube diameter beforehand helps us greatly, because we can design the timing hoppers to have smaller diameters for the product based on the target weight. It makes a much easier transition if we have the whole collection together and not touching the sides of the forming tube as it's traveling down to the bagger.
Right. Cool. So thanks, Carlos. Another big topic around products that need to be dosed with a scale is maintaining product integrity. So Kyle, can you walk us through some examples of best practices for managing the charges of fragile products?
Yeah, for sure, Emily, thanks. Brittle or fragile products are complicated to pinpoint because the same solutions for one customer may be completely different for somebody else. Some examples are baked items. They're easy to distinguish if you broke them for chips, crackers, or cookies. But also like chocolate covered yogurt raisins, we don't want to put impressions in them. Sugar confectionery, we want to make sure that the sugar stays on the gummies and we're not tumbling them too hard or taking away the sugar before it gets to the product jaws. Cube products like cheese or formed granola bars, we don't want to dent the corners as they fall. And last but not least is the peeled apples or grapes. For those who are unfamiliar, if you damage sliced grapes or peeled grapes, they turn transparent, and then a couple of days later, they turn brown. Multipond obviously tries to be transparent in handling these. We don't want to damage them at all. But the operation of the scale is to break out the flow of product, weigh them, and then put everything back together. So there's some inherent drop points and some few areas of attention that you may need to look at. Some of them drop points, number one is the conveyor to the bulk feeder or to the scale. This is probably one of the larger drops besides the funnel that's inside the scale. Some remedies that we've thought of is that there's a slide that we can put in between to help the transition from one to the other. Another that we've used before is to drop some of the products on top of it themselves, especially grapes. It helps drop the height drop a little bit smaller, and it kind of gives a little cushion as it gets to the top. Another thing to consider is the size of the scale. Obviously, the bigger the scale, the more accuracy, the higher the speeds you're going to have output. But for delicate products, we want to kind of reel that in a little bit. The bigger the scale, the wider the funnel that you're going to have. So with a less wide funnel, you can decrease your height, and it helps kind of collect things together. Multipond designs as low as 10 head scales all the way up to, so if you're considering like 20 head, we can have you maybe possibly look at a 16 head to help with that funnel height. Number 3 is the funnel to transfer from the scale to the bagger. It's always that gray area when the scale drops it. Is it now the scales or the bagger that needs to fix the problems? Multipond likes to take care of those up front. One of them being is reducing the angle of the funnel. It helps reduce the product velocity, and it helps less tumbling of certain products like cookies and crackers or grapes. Multipond also adds a impact absorber on the inside of the funnel. It kind of looks like a small little squid. We can dangle rubber or stainless little fingers down, and it kind of gently braces the product before impact to the bottom. Last, but at least for the Multipond's perspective, is that we can add a timing hopper. There's another slide later on, I'll talk about more about this, but it offers a great midpoint between the scale and the bagger. It reduces the drop height, and it kind of defines the scales roll versus the bagger roll, because we will take responsibility of collecting things and then depositing to the bagger during operation. My biggest example that I can give is we did a recent project with keto cookies. Keto cookies, they taste great, but there's no sugar or syrup acting as a glue agent, and they are very brittle. Some of the things that we did is we reduced all the drop heights within 3 inches to the scale. We quoted a 16 head scale with a 45-degree funnel. It was large enough to get accessibility for cleanability, and then small enough to make sure everything slides in gently. Of course, we had the impact absorbers, and then we had a timing hopper that opened with only one side of the flap that would open and close, and that helped slide and guide the cookies into the bagger inlet.
Cool.
Mm-hmm.
Thanks, Kyle. So
Emily,
go ahead, Carlos.
I would like to add that from the vertical form, fill, and seal machine perspective, there are also measures that you can take to handle these delicate products. Of course, as Don will probably mention, is the use of a continuous motion machine also makes the impact at the jaws smaller. So the impact, the velocity, the difference in velocity between jaws and the cookies that are falling is reduced greatly. And you can also use inclined vertical form, fill, and seal machines. We at ROVEMA will even have an execution that you can adjust the inclination of the vertical form, fill, and seal machine. So that also an alternative. And those are the main measures.
Thanks for giving us that alternative perspective, Carlos. I didn't want to gloss over that, so thank you for reminding me. And thanks, Kyle. So for our next case, you can really run into issues running these, especially when climate can be an issue, and cleanup especially can be a pain in the you-know-where. Don, you brought up some great points around best practices when running sticky products. And when we all met together, you had an interesting story. Can you catch us up on the story that you told us about running sticky products?
I don't really remember which story. I probably told you a couple.
Oh.
But running sticky products is very, it's can be very challenging. The biggest thing running sticky products is, number one, to keep your product in a nice, clean charge between each drop. We have to have a certain amount of space in between each one. But the timing of sticky product is very critical on any machine. The timing of it is keeping the charge, the leading edge of the charge, in contact with the jaws as soon as they close, gives you the maximum amount of settle time, and properly sizing the forming set to the amount of product is crucial. Also, when you're utilizing these multi-head scales, sticky products are most likely going to be recommended to use a timing hopper, where you can actually pre-shape this charge to fit your forming set or the inside diameter of your forming set. The more you touch a product, the more likely it is to slow down. Anytime your product touches your tube, and I believe Kyle mentioned this a moment ago, whenever you touch anything with this product, it slows it down, and also it strings it out, and it will also cause it to bounce from side to side and or swirl. So releasing the product into the transition funnel, which is guiding the product from the scale to the bagger, to the forming set, you don't want to have a lot of product is inherent to run around this round tube, and we call that swirl, product swirl, and or bounce when it bounces from side to side. Anytime you get any of this action, you're slowing the product down, and that's going to create two problems. Number one, if you can't control that, then the only option you have is to slow the machine down, which no one wants to do that. And number two, it's going to cause product in your seals. And when you get these sticky products, such as candy or gummy products with sugar and everything else, if you get one piece caught between your jaws, you lose two bags automatically. And then you contaminate the following bags because your jaws are now dirty. So keeping the product charges in a nice clean shape, keeping your timing perfect as perfect as you can get it, utilizing your timing hoppers and everything. This speeds everything up. Cleaning your jaws is something that you have to actually stop the machine, which means you're taking it out of production, and clean your jaws. We have products that are used specifically for cleaning chocolates, or just not chocolates, but anything that is heavily sugared or any kind of sugar at all. We have products for that assist in cleaning your jaws from this material, utilizing a brass brush, and then you have to clean your knife slot with a plastic device to keep from damaging your jaws. So anytime you have to do this, it's taking you out of production and it's costing you time. So although we have developed cleaning methods and these cleaning products and stuff like that, it still costs you time, production time.
Right.
So we want to keep these products as closely timed as possible, which means in the beginning, it's like Kyle was saying, the customer needs to make sure that they're explaining characteristics to us and to all parties involved in the project. If you have a product that's very difficult to handle, we need to know about this in the beginning and be very transparent about it, so that we can, there's so many ways of attacking a specific product issue that, I mean, we could talk for days about sticky and gummy products.
Yep.
But also to come back around to what Carlos was saying about gentle handling of products. Yes, we do have machines known as continuous motion machines. We have a lot of products that are coated with a hard shell candy on the outside, chocolate on the inside. These products, if they get fractured, if you fracture the outer coating of these products, it reduces the shelf life by half. So we have developed this continuous motion machine, which gives us the ability of a non-violent impact on top of the jaws when they close, and the product is being released from a scale 4 feet, 6 feet above us. They gain a lot of speed coming down through there. So with our jaws in a downward motion, it reduces the impact of that product. So high breakage products, product stability, and it also gives us the ability to go faster with these products.
Right.
So, but messy products are, every product has its own characteristic. So
Right. Thanks, Don.
you're welcome.
And I do want to point out, Don, you mentioned minimizing the contact of the product with the equipment so that you minimize the amount of sugar that can be knocked off or slid off or melted off or any of that. But then, Kyle, for fragile products, you want to maximize that contact and soften the travel and slow it down if that is the best solution for your product. So that's just an interesting parallel that I wanted to point out.
You have to weigh it out, between speed and product protection.
Yep, for sure.
So there's many variables involved in this.
Well, and I'll pose another tendency that we'll have, Carlos. I'm going to bring it back to you. Product bridging can be a huge issue when it comes to high-speed packaging of products like produce, which we have pictured here, or even baked goods like Kyle mentioned, sometimes like powdered donuts. Carlos, do you have some examples of maybe some additional products that have this tendency and some best practices around running these?
Yes, Emily. The picture you picked for this slide is perfect because it's the shape of the product that sometimes gives you troubles with how the charge behaves entering the vertical form fill and seal machine. And as you mentioned, for fragile products, we want to maximize contact. For sticky products, we want to minimize contact. For a high speed or some application, we want to keep all the product together, in the charge of the product, everything together and release it in one time. But for these kind of products, you sometimes need to separate the products a little bit and to let it string out with a function that many multi-head weigher have, is a staggering charge or a staggered charge. So the product is released with milliseconds of difference. So you get a string of product that will get into the forming tube easier without causing bridging and without clogging the forming tube. This is an example that's very good one with the green beans. And that is very useful, this staggering function. Also, sometimes the products can produce this bridging, not entering the vertical form fill and seal machine, but inside the bag. And when this bridging occurs, the product takes up a lot of space inside the bag, and sometimes the space that it takes is bigger than the volume of the bag itself. So you end up with products between the jaws, which is something you want to avoid at all costs. And we can use additional functions for this. There is a way that you can produce a bulge in the bag before the products enters into the bag, and that increase the volume of the bag before the products enters in the bag. And even when there is some bridging, as the bag has more volume, the product will arrange itself in a better way and will allow you to run either shorter bags, bigger speeds, or without any interruptions in the process.
Awesome. Well, thank you, Carlos. So for our last case study topic, and Kyle, you kind of brought this to our proverbial table. Tell me about your recent experience with a customer that was trying to evaluate if a timing hopper was necessary for their products. What what's kind of the criteria they would use to evaluate this? And can you also dive into the role that the component plays? We've touched on it some, but I think that the way you described it was really cool when we talked about it before.
Yeah, thanks, Emily. To be completely truthful, in 10 years, it's probably the first time I've talked about the timing hopper and the operation in detail, because 95% of our applications include a timing hopper, and it's kind of like a standard, like that's what the Multipond does. There's some outlying circumstances, just like Carlos said, where you need to stagger it and have it, you're forcing it to line up. Sometimes we are being really slow and we're doing like CBD type things where accuracy is much more important than speed. Or sometimes we're putting gummies in a bottle where you don't need to have a timing hopper. Majority speaking, a timing hopper is very important. Without it, there'd be a lot more issues, swirling, as Don said, like we see with round products or maybe grapes. Sometimes we see products that bounce a lot and take a lot of cycle time, like square, like cube cheese, product separation. When we deal with smaller granular products, they become spread out, so that charges between each other for the bagger to close its jaw. We're wasting their time to get everything together. So timing hopper helps control the product at all times, and that's kind of the main purpose of the timing hopper, is to not guess where the product is and where it ends. It's just keeping everything together. Try to drop it all at one time, try to limit how much wasted time between one shot to the other. Increase the cycle speed. I know the baggers appreciate it because now they have clean seals. But in order for us to increase speed is that we can actually drop multiple dispenses mid-flight. So there's one going down the funnel. So there could be another one in the timing hopper. There could be another one down the funnel. So where I'm trying to go with this is that timing hoppers kind of help that separation between one bag to the next, and then limiting your downtime overall. Timing hopper is also great because it eliminates the gray area between one equipment to the other. Multipond, we will take responsibility all the way down and deposit, and then we know the bagger's responsibility is to make the bags to do their part. So without it, products will fly all over the place. It swirls. You know, everyone's kind of got a finger pointing. Who's going to fix it? Who does what? How can we get it better? A timing hopper draws that line in the sand, saying, "All right, we're getting good product. We're dropping it. Everyone's happy." As I mentioned before, the timing hopper acts like an intermediate safe point. We, instead of dropping it 10 feet in the air, now we're limiting it right above the bagger inlet, which could be 4 feet, 3 feet. Again, it helps with limiting that chance of errors that we can't see, is swirling, the staggering, all that kind of good stuff. Operation is very, very simple from our perspective. The scale runs the power. There's no air included. And the timing is customizable right to the HMI of the scale. Within the last 10 years, Multipond has advanced this timing hopper. Typically, normally, you'd see like a standard duckbill or a 2-door opening. We make them in 2 designs with the duckbill, which allows the product to be pointing down and helping get the product as soon as possible to the bagger. It kind of keeps everything intact and makes sure not touching the forming tube. We also make a clamshell design that's more popular for larger applications, for large bags, large target weights. The picture you see on the screen is more of our newer design. It's an alternating swiveling timing hopper. With this technology, we can go up to 180 to 200 bags a minute. And how it works is that one side is filling, collecting, and the other side is dispensing. So it kind of does everything I've talked before about collecting everything, putting them together, dropping them, except now we're doing it in an alternative rotation manner. This one's especially very unique. The flaps open sideways in reference to the motion of the timing hopper. Something we designed in the last year that goes up to 200, 210 bags a minute. Something else I want to point out, we talk about timing hoppers, we talked about the timing. Something else I want to talk about is there's other solutions that we can offer or look at for everyone to look at. Is maybe having a plate on the inside of the funnel of the scale, which helps take up the volume because that scale could get very large. My biggest example is gum, cubed gum, where it bounces from side to side around the funnel. Multipond had a hard time. And a very simple solution was to add a small backboard. And it takes up that time for that stuff to settle. So taking things small, having simple solutions, timing hopper, impact absorber, all kind of helps that cycle speed.
Cool. And I wanted to interrupt too with a question that popped up that seemed really relevant. Do you think that this would help make sure that product has time to settle and that it kind of helps to mitigate dust?
Yeah. So from a scale perspective, everything wants to collect together. So we wait for that last bit of piece of dust. In our world, we call it a dump time. It's pretty much what gravity takes from the product to get from the weigh hopper to the timing hopper. Some products are different. So if we're running M&Ms, they race, they get there very fast. If we're running chips or cheese, it takes a little bit more time. But in my experience, the best thing we can do is have a high-speed camera, and then we run it, and then we see what that dump time takes to get from one point to the timing hopper.
Cool. Yeah, so just to bookend this segment of today's presentation, before we dive into some more questions, we do want to leave you with some party recommendations. The first is, if you're going to go through the process of building out a packaging solution and you're using components from different suppliers, the most important thing that you can do, that you should be doing, is including them on any engineering discussions and also having them talk to each other to spec out the best solution for your products. Obviously, Kyle is no stranger to the ROVEMA folks when a scale is required for a packaging solution. So team, what are some other final takeaways that you want to throw out to the group? Maybe some hacks on how to troubleshoot some of these issues. Just throw them out there.
I mean, I'll go first. I know transparency, that's always the big thing from small details to the other. I'd always like to take things simply. Solve one solution before you're trying to solve the whole thing. Cookie breakage, focus on the top of the scale. See how you can stop breakage there first, and then kind of do a waterfall effect. Keep looking your way down. Try not to work on the biggest issue first. Try to do the small stuff and work your way to the hardest stuff.
I have something that I forgot to mention earlier is there, like we were saying, there are different things, but the best way to see what your product is actually doing at the end when it's actually filling the bag, you have a couple ways of doing this, and it's just a little trick. Number one, you can put clear film on your machine where you can see how your product is reacting as it comes out of the forming set. At that point, it's in a free fall stage. Nothing else is going to touch it but the bag. So to see how your product is landing on the jaws, how it's coming through the forming set, if it's being strung out, or if it's bouncing or swirling, or if you have late pieces falling, clear film is the number one choice. But if you don't have clear film that is the right size and the right makeup to run this bag or to run on the bagger, you can also take a drop light or a trouble light and place it on the faceplate of the machine behind your jaws, just above your jaws, and allow the light to shine through. And you can see the shadow of your products falling down through there. And you'll see if there's late pieces, if the charge is arriving nice and clean. If it's being strung out, you can see the same thing. So that's just one little trick that you can use to see what your product's actually doing, how it's behaving.
I'll go next. as Emily mentioned and Kyle also, share all the information you can about the product. There's one particular data that it's always missing is the density of the product, and I believe that some project engineers don't understand how important it is for the weigher, and also for the bagger, and also for the format definition, because you may have a machine that's running 40 bags per minute now, and you want to increase the speed to 100 bags per minute. But sometimes the amount of product that you are putting in a bag at 40 bags per minute, it's not possible at 100 bags per minute, and you have to do some adjustment in the volume of the bag to have the appropriate head space. And sometimes there are small tricks that you can do. Always small forming widths, so forming sets that are very narrow are always more difficult for the product to settle. It's always more difficult to get all the product inside the forming set as well with these very narrow forming tubes. So if there is no objection from the marketing team, you can probably work with this a little bit and increase the speed and increase the performance. And at the end of the day, you will get a better return of your investment, because the machine will be able to have a better throughput. And that's something that's always we're looking for.
Cool. Does anybody else have any pointers?
Other than, we realize what a high stress industry that we're in with food packaging. You stop for a minute, you've cost thousands of dollars, you've lost so much money in production. So we understand how stressful it can be. And that's why we're here today, is to help. And not just today, but anytime. Anybody can call us at any time with any type of questions. We're always here.
For sure. So we do have a couple of questions from Jeffrey, and I think that he is really just wanting to understand how to evaluate the distance from the filling agent to the jaw set, particularly for small format packages. Is there kind of a rule of thumb?
Yeah, we do have, sorry. We have a limit, and it's the transport belts that really limit us. Our transport belts are made for pillow bag and or a flat bottom bag, but we have to stop the bottom of the forming tube at the middle of the bottom pulleys on the belts, because at that point we go from pulling the film down the tube to pushing the film at that point. So if we have film that fits tight around the forming tube, it's really hard. It's kind of like pushing a thread or a string or a rope, So when you extend that tube past that point where we stop pulling and start pushing the film, you run the risk of the film bunching up at the bottom of the belts. The film is still on the tube, but it affects your bag length, and it also can cause you product between the seals and things like this. Now, when we run a flat bottom bag, our tubes are much closer to the apex of our jaws, where the jaws come together. We have 4 to 5 millimeters. We actually turn our transport belts over so that the belts are down close, very close to the bottom of that forming tube. And we're only pushing the film 10, 15 millimeters. And then again, this also comes into effect. where we can utilize what Carlos was talking about earlier, which is the bulging factor. He was talking about bulging the bag out. And at that point, if the film is bunching up, we can actually turn that around and actually have the jaws pulling the film off of the bottom of the tube while the belts are turning and transporting the bag. So there are things that we can do, but that's our normal standard of operations with forming sets. When we size the forming set, we size it to the bottom of the pulling section.
Cool.
More to come later.
So we are a little over our time limit. If you did take the time to submit a question, again, look out for a response to your answer in a follow-up email. Jeffrey, I know that you said you've got some more questions that'll be coming, so we're looking forward to catching up one-on-one on that. I do want to just thank you, gentlemen, for joining us and giving us some great insights from, your drastically different perspectives on the packaging industry. And I do want to personally thank all of our attendees for listening in today on our webinar. I hope everybody enjoys the weekend and it is safe and toasty. We will see everyone on our next webinar.
Thank you, Emily.
Thanks everyone for joining us.
Appreciate that.
Thanks, everybody.
Thanks again. Bye.
Thanks, y'all.
Thank you.
Bye, guys.